Our next unit is something on the lines of functions. So up to this point, you've watched something about the function machine, and now we're going to look at some different ways that functions can be represented. So on this first one, it says the mapping shows a relation of x and y coordinates. So if we notice here, we have our x coordinates and we have our y coordinates, and this is essentially creating a coordinate pair. So this could also be written like this: x, comma, y, that would be that way. And then each of these would be coordinated in a coordinate pair. So our job is to ask ourselves, does the relation represent a function? So we need to say a yes or no and then explain our answer. So a function means that each x value, which is our inputs, is only connected to one output. So we need to make sure and check each of these. So 1 is to 3, 2 is to 6, 4 is to 10, and 5 is to 20. So since each input is only related to one output, we can say that yes, because each input is related to exactly one output. All right, so thinking of a map, a mapping is one way that we can represent this. Okay, now it says to plot the points from the relation shown. So let's go ahead and maybe zoom in a little bit. So our first plot is -5, 3. So we're going to start at the origin and go 1, 2, 3, 4, 5, and up 1, 2, 3. So that's going to take us here. And then we're going to go -3, +5, 0, -1, 1, +2, and 4, +5. So those are our points plotted. And now our question is, use the vertical line test to determine if your graph represents a function. Explain your reasoning. Okay, so let me get a vertical line. So I'm going to go ahead and create my vertical line for our vertical line test. And let's see. So our vertical line test is going to tell us that this vertical line that I'm going to drag across, so I have my vertical line, I'm going to drag this across my coordinate points, and there should be no points that touch the line twice. So here we're good because we only have this one point that's going through. And then if we keep moving it, we just have 1 point. We have 1 point, 1 point, and 1 point. So for this set of relationships of inputs and outputs, remembering that the x's are inputs and the y's are outputs, we can see that with our vertical line test that this yes, because the vertical line doesn't pass through more than 1 point at a time. Okay, let's go up to number 3. So here we have a relationship shown. We're asking if it is a function, so we need to explain our answer. So we need to check if we have the same amount of inputs and outputs. So I think that we need to make sure that none of our x's are repeating. So we have a -1, and then we have a 3. So far we're good. And then we have a 4, and then we have a 6, and then we have a 10. So here we have each input, yes, because each input, which we have to remember are our x values, has only one output, which are our y values. Okay. So now they gave us a set of x and y's, and now we have to put them into a map just like we saw at that first example. So our x values are going to be all of our first coordinates, and then our y's are here. So we're going to take each of these and put them into our grid. So we have a -3 and a, let me make sure, a -3 and a +1. So a -3 going to a +1. We have a -2 to a 2. Then we have a -1 going to 0. And then we have a 0 being connected to a -1. So we've had different x values so far. We had a negative, we haven't had any repeating. And then this last one here, so we see a -1 here, but we've already seen a -1 here. So we don't need to rewrite that in the x value because we already have one. What we need to do is extend. So here's our -1 that we already have written, except here we see that there's a -2, which is different than the 0 that it originally outputted. So the y is going to gain another, and this -1 is also going to be attached to that -2, which means that each input produced more than one output, which makes this not a function. So let's go ahead and write that. No, because the input, the x, -1, produced more than one output, which are our y values. So that runs into a problem because we are creating, it's like putting a quarter in and asking, pushing A1, or in this case, a -1, and wanting a bag of Takis, but then getting a bag of Doritos instead. So the input, the function, this function is not working properly. All right, and our last one, determine whether the following relations are functions. If the relation is a function, write function. If not, change one or more of the numbers in the table to make the relation a function. So we can go ahead and start by looking. So we see a -14 to a 7, a -10 to a 5, -6, 3, -2, 1, 2, 1. So on this side, so from here, we have a function because each input is related to only one output. So now let's check the second half. We have here a 5 to a 2, a 3 to a 3, a 1 to a 4, and we have another 3 here. So let's go ahead and highlight that. We have another 3 here. So this and this one's going to a 3, but this one here is going to a 5. So that looks like a problem. Let's check the last one, a 7 to a 6. So our 3 is our problem here. So in order for this to be a function, this second one or this first one, they either need to create the same thing. So this 5 here can't be a 5. This either needs to be a 3 in order to make it a function, or there are like so many ways that we could fix this. Let me just make a little list over here. So we have our x and our y. So if it was going from a 3 to a 3, we'd either have to change that first 3 to a different number, or we could change the second 5 to a 3, so it's producing the same thing, or changing the x value to a different input. There are so many ways as long as the function gets changed so that each input only changes to an output. So I'm going to go ahead and just change this 5 to a 3, and then that would make it a function. And you can change it in another way.